stateless servers unlock the real horizontal scale. Your load balancers work until users start randomly logging out. Welcome to the stateless versus stateful problem. Let's take an example and see what happens through code. First, we'll store some basic user information in a dictionary. Think of a dictionary as memory inside the server. When the user calls the login endpoint, we create a new session ID and store that in the dictionary. When the user calls the profile endpoint with the session ID, we try to retrieve that session ID from the dictionary. If that session exists, we mark that call as successful. If it doesn't, we fail that call. Now let's create a sample session ID by calling the login endpoint. Over here, we can see that we created a session, but that session was created on the virtual machine number 2. But now what happens if we perform the load test on the profile endpoint through our load balancer? Here is the interesting metric. We can see that there were 30,000 requests made within the load test, out of which 50% of the requests failed. This means that the load balancer has done its job perfectly. It distributed the traffic between the two servers that we have. We have the VM1 and the VM2. But here is the issue. Our session data was stored on the VM2. But when the request hits a different server, the whole stateful server flow breaks. This is a stateful architecture. Your session data lives on one server, but your load balancer doesn't know that. Whereas in a stateless architecture, every request is independent. That means you can independently add or remove any servers without being concerned on what server the load balancer will hit. And that is why